CSA Mine has only recently departed the Glencore mothership. We're now Metals Acquisition Corp, which is a Texas-based company and trading in Australia as Metals Acquisition Limited, headed up by Mick McMullen, and locally we have Nick and Nev Power. Started out at the CSA originally in 2021 with the introduction of a Sandvik fleet, which was the I-series machines, the smart machines, and the introduction of the BEV come along to me as almost as an afterthought. It was just mentioned to me one day we had a battery machine coming. And at the time, bringing on a new fleet, an orange fleet, on a mine site that was predominantly a yellow site was a handful as it was, but bringing in a battery one was definitely a handful. The Sandvik fleet is all data-based. Most of it goes into the cloud. Our actual site doesn't have Wi-Fi as such. We're slowly getting nodes underground, but it is taking some time. That also created the issue with the battery electric machine, because it also, all its data goes to the cloud, and we had no Wi-Fi down there for that either. So this is focusing on the introduction of a battery electric loader to a diesel fleet at one of the deepest underground mines in Australia, the CSA mine, high-grade copper operation in Cobar, New South Wales. The analysis of a trial battery electric loader compared to existing diesel machines is performed with regards to infrastructure, technical and operational issues. The key benefits of the battery electric vehicles over conventional diesel-powered vehicles are discussed in this paper, including the lower energy consumption, greater efficiency, reduction of emissions and heat, reduced need for ventilation and lower operating costs. Challenges of introducing the BEVs into an operation along with the results from the comparative studies are addressed under the impacts of energy consumption, equipment selection, effects on ventilation and cooling, the mine design, economic viability for future fleet implementation scenarios with meeting these targets. So the diesel-powered mobile equipment dominates the modern mining for materials handling, such as load and haul, the LHD machines and trucks. These heavy vehicles can constitute a significant source of heat, exhaust gases, diesel and particulate matter, noise and vibration. Assuring enough fresh, cool air to remove atmospheric contaminants from the underground environment for miners, particularly as mines progressively become deeper, where ventilation constraints and associated operating costs have an increasingly adverse impact. A critical step to improve working conditions in underground hard rock mines by reducing diesel-powered machine contaminants is proposed to replace these with electric vehicles which produce none. Despite many advantages, few underground hard rock mines globally use electric vehicles, typically due to market availability, battery life, change-out and charging times, safety concerns and the battery technology. A new generation of reliable BEVs, battery electric loaders, is now available through manufactured with recent developments in the battery technology, offering the same flexibility as diesel machines to make a business case for a potential transition to a cleaner fleet to prove their viability in real mine conditions. So a bit of an overview of the CSA mine. We're out at Cobar, Central West, about 700 k's northwest of Sydney, central western New South Wales. It has a long history. It's been mining since 1871. It's had a fairly erratic history up until 1964, when Broken Hill South began large-scale production before passing it over to CRA in 1980 and Golden Shamrock in 92. It closed for a while in 98, following an acquisition by Ashanti Goldfields, and then Glencore reopened it in 99 under a whole-owned subsidiary, which is CMPL, Cobar Management. The CSA mine consists of a deep, high-grade underground mine producing 1.2 million tonnes, copper ore processed on-site, producing about 165 kilotonne of copper concentrate. At a current depth of 1875, actually I think that's a bit deeper now, and ore averaging 4% mine grade, some as high as 12%. CSA mine is one of Australia's deepest underground mines and one of the richest copper deposits in the world. The underground mine is serviced by 2 hoisting shafts and a decline. We're actually drilling at the moment down at the 2200 metre mark, so we're a long way down. So where our battery loader's operating at the moment is at the 9 level, so it's about halfway down. It's at the bottom of the main man cage that we run with. Unlike diesel-powered machines, electric vehicles offer significant benefits, producing no toxic gases, no diesel particulates, reduced vibration and significantly less noise. Furthermore, electric motors are significantly more efficient at around 95% and therefore produce less heat through energy loss into the surrounding rock, equipment and the environment. Conversely, a diesel-powered mobile offers advantages over the electric equipment, including lower cost purchase and fewer infrastructure requirements. Now, the Epiroc ST14 battery electric loader, numerous changes in key personnel have occurred. So that was actually ordered back in 2018. I arrived late 2020, early 2021. So it had been in factory, in build for nearly 3 years as a prototype. And as everyone knows, you never buy the first of a model. We have had problems with it, but when it is operating, it operates very well. The battery electric loader purchased to conduct a trial based on those available on the market at the time was the Epiroc ST14, designed on the diesel scoop tram ST14, having the same exterior dimensions and appearance. It has a 14-tonne tramming capacity and an 18-tonne breakout. Other key mechanical features include a 4-speed automatic transmission, fully enclosed wet brakes, liquid-cooled motors where they actually normally would sit in where the diesel engine is. It runs ABB 200 kilowatt traction motor, ABB 160 kilowatt auxiliary motor for a combined 360 kilowatt of power. It's driven by 4.5 tonne of lithium-ion batteries, and they're situated actually in the old engine bay. The Li-on battery pack has 4 sub-packs with liquid-cooled cells and integrated thermal management system. The 360 kilowatt battery, having a usable 300 kilowatt, is charged by a ABB 850 VDC source via a CST2 plug, which is basically your Tesla plug. Okay, so we had to run some trials on this machine, and that was part of the original deal with Epiroc to take on a prototype machine. So following a thorough safety, mechanical and electrical onboarding to site, a phased approach was planned for the trial of the ST14 at CSA mine. Operator training, commissioning of the loader took place on the surface prior to going underground for placement at the 9-level transfer. So the initial trial, or trial 1 as I'll call it, the first trial involved rehandling stockpiled oil into the crusher in a localised area with minimal gradient, so it's fairly flat. Observations of tractive effort, breakout lifting capacity and fill factors were made. Similarly, hauling on dumping cycles were monitored when tipping over the grizzly bin into the crusher. So that particular run that we do on to the crusher is a few hundred metres out of the stockpiles where the ejector trucks are pushing up. When we have too much going into the 10-level crusher, the excess is going onto 9-level and the ejectors are pushing it into stockpiles, and then this machine is actually transferring it back onto the grizzly. The run times range from 2 to 4 hours depending on the operator, and charge times were in line with the original equipment guidelines, being up to 2 hours from a depleted charge. Now this machine, depending on which operator's in it too, they can kill a battery in 2 hours, but man, they move some dirt in those 2 hours. The bucket itself will actually hold 22 tonne. They're rated for 17, but they will pull 22. And in that 2 hours until they start depleting the battery, they've pretty well emptied the stockpile anyway. Other operators actually use the machine a bit slower and we get 6 or 7 hours out of it. Trial 2, second trial was performed with a loader driving down to 10 level feed the shaft 1 crusher with waste. In this trial, regenerative braking functionality was confirmed, along with quantifying the depletion of state of charge when tramming the route back to 9-level station. The battery regen going down, while tramming downgrade was positive, increasing it to a full charge over the 2.1 kilometre run down, while 15 to 20% depletion on the battery occurred travelling the 2.3 back up on the loop on the upgrade back to 9-level. That battery, its zero is actually 20%, so you always have 20% reserve so you can get off the decline or back to the charging station when all the warning bells and buzzers go off. In trial 3, a third trial was conducted to compare the ST14 to the remainder of the fleet, being the diesel powered, with respect to impact on environmental conditions. Hamish Ray has written a paper that's probably well worth reading. He's our hygienist on site, and he looked at the conditions between the actual battery machine and the diesel machine, the effect of vibration of a diesel engine on the long-term impacts on a human body, compared to this thing, which actually has no vibration at all in them. It's an incredible machine to operate. Both diesel and battery electric loaders perform simulated loading cycles over a 2-day period, consisting of travelling forward to the face of the drive, bogging fragmented ore, reversing to the stockpile and completing a lift lower cycle. Variables measured during this trial included the heat impact to the ventilation system, wet and dry bulb, atmospheric contaminants, internal and external noise levels, and whole of body vibration within the cabin. Temperature, the thermal environment measurements were conducted using a K-Law heat stress monitor. The measurements were taken in the local ventilation airstream for dry and wet bulb temperatures, along with the globe temperature and relative humidity and an airflow. Combination of these measurements impact workplace conditions and perceived conditions felt by employees when considering latent heat of vibration in additional to the sensible heat. The data for the 517 Sandvik that it was compared to indicated that the ambient temperature increased in the area they were bogging with a realised temperature of 14.6 degrees Celsius. That's as an average over the hours of the test. From the baseline in the ambient temperature, both during and after completion of the test. Conversely, the wet bulb temperature was lowered following the test, and that's probably due to the change in the relative humidity. The ST14 bogged 50 minutes, repaired vent, had a vent tear, so we had to pull it up halfway through it, but it doesn't seem to have affected the figures, but then it continued bogging for another 41 minutes. The state of the charge decreased from 99 to 73% during this time. 17 buckets were bogged, and before commencing tramming back to the 9 level, the state of the charge further decreased to 50% during the tram back up to 9 level to the charger. Anecdotally, the 517 produced more total heat than the 14, in line with what you would expect anyway. Atmospheric contaminants. Again, we used to test this, we used a Draeger 5000 monitor. No gases were detected, obviously, from the 14. With the fugitive dust while bogging with the Epiroc loader was substantially lower than the Sandvik loader. Plausible consideration to that is the dust made airborne wind generated from the radiator fans and the engine exhaust on the 517. Anyone that's used the Sandvik machine will realise that all the cooler pack fans actually blow out. They don't suck in, so they create a lot of dust off the walls of your drive. And that's one of the reasons we moved towards buying some Elphinstone water cannons as well, because they have side mist, so they can actually take the dust off the walls. The noise emissions carried out in accordance with Australian Standard AS 1269 and the New South Wales Safe Work Code of Practice 2019, which is managing noise and preventing hearing loss. We used a Natta calibrated Brule and Cager meter The ST14 generated noise levels of around about the 69 dBA outside the cab. Comparatively, the Sandvik machine, the 517i, produced external sound levels of 93 dBA, so substantially louder, obviously again from the diesel engine. The higher values also were returned on either side of the rear of the loader on the Sandvik. An external difference of 33 dBA between the loaders equates to 15 times lower sound pressure than the electric loader. The operator feedback, that was very interesting. We badly introduced the Sandvik machines to our site. Operator acceptance on an orange machine over a yellow one was very slow, and a lot of pushback. Obviously we had the same thing with the battery loader, because even though it was yellow, it was a whole different machine to operate. Overall sentiment from the operators has been mixed from the onset, associated with acceptance of new technology in a different machine, reluctance to adopt and embrace the change to a different manufacturer as well as a non-diesel powered loader was soon overcome due to the positive environment and ergonomic benefits. So most of these operators had climbed out of a 2900 Cat, which is pretty well a brick on wheels, and into this machine, which is similar handling to a Sandvik machine. They're quite comfortable, very soft ride. During the introduction of the ST14 battery loader and various trials conducted, the employees were surveyed on their opinions on working conditions relative to the diesel machines. All respondents noted improved environmental conditions of reduced noise, heat output, in-cabin vibrations and improved air quality with zero emissions. Similarly, the operational benefits of speed and manoeuvrability from a high-powered traction machine with high efficiency driveline and separate auxiliary motors. It's a very fast machine, this thing. It's mechanically less complex, obviously, without having a diesel engine. Fewer moving parts. The battery removal, you can pull the battery out of this thing in about 3 minutes flat. And once the battery's actually out on the floor for our fitters, all your hydraulics are just laid out in front of you, just climb in and it's all easy to get to. Conversely, the employees did not like the frequency at which the battery had to be charged, impacting the productivity, supply of future batteries. The quiet nature of the machine, the potential fire risk for the battery pack. Respondents were indifferent to the physical and mental effort required to operate the machine and work performance when loading. So again, the introduction of the machine was not probably managed very well. We told them it was coming and we just told them they were going to use it. We should have probably done a lot in the lead up in that 12 months until they started to use the machine. Overall, as a trial unit for the CSA mine to start its journey into battery electric vehicles, the Epiroc ST14 has proven useful. As I mentioned, there's been some teething problems because it was a prototype. The problems included the transmissions, because it has so much power and it does have traction, because that's the way it's designed. The transmissions didn't handle it, so the transmissions have all been beefed up. Being a prototype, can't buy anything off the shelf for it, so everything has to be handmade, so all the wiring looms. Yeah, pretty well just about everything on it is handmade, so very hard to buy parts for. We're in the process of talking to Epiroc to trade that machine back for one of their new production ST18s, which would be a bigger machine for us to use. Now, I'm no expert at all on batteries, so I'll just run you through a few slides from Epiroc as to what we've got. The batteries, there's hundreds of batteries in each of the 4 sub-packs. They're just a tiny battery. They're only 100 mil high, 15 or 16 mil in diameter. A lot of this is from Epiroc, of course. So when we were setting up the battery charge bay, we had no Australian standards to work to at all for actually putting the battery bay in. So we used all international standards and we picked the highest level of standard for each area that we were talking about. I'll go back to where that unit is parked. In there, we're in an airway, and the way the battery pack is designed is it's got a deluge on the battery pack itself as well. The valves to turn it on, which will deluge the battery, are at either end, so it doesn't matter which end they run out. They just turn the water on and it'll flood the battery pack. It runs FSI fire suppression on it, as well as all the handheld fire extinguishers. Again, I'm no battery expert. They're lithium-ion batteries, of course. They're all sealed, so they can't vent. It'll show you on here where you can see the red lines on those batteries. So when they need to vent, of course, all they'll do is flex the plate inside the battery, so it'll take up the difference in the pressure that's inside that battery. That's the battery pack. So the battery pack is, as I said, we lift it out. It's 4.5 tonne. Lift it out with a forklift or a IT. We've actually got it under a crane. The battery pack itself, we have had no problems with. It's all the electricals that lead up to that battery pack. The battery pack itself, I haven't got the slide with me, but when Epiroc did the tests in Sweden on the batteries, each of the packs, which, as I said, there's 4, is equivalent burn to 50 litres of diesel. So it has an intense burn period of 20 minutes, and then the intensity drops off over the next 20 minutes until it goes out. Toxicity is a whole different thing, which is why when we designed the charge bay, it's in an airway where the toxicity dissipates quickly. Fire suppression, as I said, it's an FSI system. It's got fire extinguishers, it's got 4 fire extinguishers hanging off it. That's the battery pack out of the machine, sitting on the floor, so you can see it's quite easy to access everything within the frame. That's just our guide for shutdown if there ever was a fire. Thank goodness we've had nothing like that. That's basically the system that we use. The battery pack itself, the water deluge that we have on it, as I said, it floods all 4 packs at the same time, and through the safety instruction they just get out of the area. As you can see, yeah, that's me.